So we have this function that is f of x is x to the fourth power minus 3x to the second power plus 2, and we need to find the restrictions and the domain. The domain is x belongs to all real numbers because it's a polynomial function, and the restrictions, there's no restrictions because it's a rational function. We have to find x and y intercept coordinates. To find the x-intercept, we have to put y equals to 0, and we need to substitute in the function. Then we need to equal this to 0 and this one too. In y-intercept, we have to substitute all the x by 0.
For point C, we need to find its symmetry, and we are going to test it with the even test. And we have our function, which is, and then we're going to put our x values with negative sign. And then we're going to solve it, so we can know that it's an even function. Then for point D and E, we need to find horizontal and vertical asymptotes. First of all, we don't have horizontal asymptotes because it's a polynomial function, and also we don't have vertical asymptotes because it's not a radical function, and also because its domain is all real numbers.
So in F, we have to make the first derivative. Then in G, we have to make the first derivative, ID test. So we have to write down the first derivative. We have to equal to 0, and we have to factorize, and each term we have to equal to 0. So here we have 0, 0. So here we have x equal to plus minus a square root of 3/2 and the critical points. So from our points, we are going to choose this 4 minus the square root of 2 minus 1, 1, and the square root of 2. So we take our first derivative function, and we are going to take the first one, and we're going to substitute in here in the function. Then we need to factorize, and the result is minus 2 square root of 2. So the slope is going to be minus, and this is going to be minus infinite minus square root of 3/2, and this means that minus infinite will decrease to minus square root of 3/2. We are going to substitute with our next value, that is minus 1, in the same first derivative. We obtain 2, so the m is positive and this will increase, and the points are minus the square root of 3/2, 0. Then we take our third value, that is 1. We're going to substitute in the same function, and we are going to obtain minus 2. The m will be negative, so this will cause to decrease, and the points are 0, square root of 3/2, and then we're going to take our final value, that is square root of 2. We're going to substitute, we need to factorize, the result is 2 square root of 2, and it is positive and this will increase. The points are square root of 3/2, infinite, and we can see in the graph this point that is going to be here to the.
For each, we need to find second derivative, and we which is going to be 12x squared minus 6. Well, we take the first derivative to find the second one. So this is. Then we need to find the concavity test, and we need to take our second derivative. We need to equal it to 0, then solve it, and our x will be plus minus square root of 1/2. Then our points will be minus square root of 1/2 comma 0 and the square root of 1/2 comma 0, which is, this is gonna be our critical points and the minimum. Then we are going to take our second derivative. Then we're gonna substitute with this value, which is gonna be minus 1. We need to substitute and our result will be 6. So it will be positive and it will be a positive concavity and it's gonna be upwards. And our interval will be minus infinite to minus square root of 1/2. Then we need to choose our numbers, and we already made with minus 1. So now we're gonna substitute with 0 and our result will be minus 6. So therefore it will be negative and it will have negative concavity and it will go downwards. So our interval will be minus square root of 1/2 to square root of 1/2. Then we're gonna take the 1 and we're gonna substitute, we're gonna solve it, and our result will be 6. We will have a positive concavity and it will go upwards. So our intervals will be square root of 1/2 to minus. Our range will be from minus 1/4, which is this one, well, this, to infinite.
The connection between of the functions is that all of them are polynomial functions. None of them have asymptotes, but the 3 of them have the same domain, that is, x belongs to all real numbers.
After applying the formulas for the function, we conclude that we can find so many things in a single function, like its symmetry, the maximum and minimum point, and also we can use it also for many day-to-day situations that people face and we don't even know. Like, for example, we use it in economics to do cost analysis, also for a design of a roller coaster, for industry and physics.